Advanced Algebra 1.5. We're going to look at multiplying matrices. Now, this is not as intuitive. And so for this, the order does matter for which matrices first and which ones second. And we don't always have the same sized matrices that we're multiplying together. There's something that has to be very distinct between them. Okay. So if I take this example here and I see my A and B here. So I have A and I have B. So if I look at what my dimensions of these two are, I always look at how many rows I have by how many columns I have. So in this first one, it's equal numbers of rows and columns. So I have a 2 by 2. In the second one, I have 2 rows. So 1, 2. 2 rows, and I have 3 columns. So if I look to see if I'm able to multiply them, I need to be looking at the middle numbers here. If this middle number is the same, then these can be multiplied. Okay. So if it's in this order, these two can be multiplied. If it's in the reverse order, it is not. So I'm going to write that up here. So if I have a 2 by 2, and I'm multiplying with a matrix that's a 2 by 3, these numbers are the same, so I can multiply it. My resulting matrix is going to have the dimensions of the outside numbers. It's going to be a 2 by 3. Now, depending on what your original matrix is, you could have totally different dimensions than either one of your original two that you're multiplying together. If I switch around the other way, if I try to do this 2 by 3 and then multiplied by a 2 by 2, these are not the same, so cannot multiply these. And if anything, we would say that this multiplication is undefined. So let's go to our case that we can multiply. Now it's important to know how large our new matrix is going to be. So our new matrix is going to be a 2 by 3. We have 2 rows and 3 columns. So I'm going to set this up where I have 2 rows and there's 3 columns in each of those rows. Now putting those lines there are going to help us to be able to know what we're working with. So that aid is going to be really useful when you're multiplying. Now the way that we do this is that we're using rows of our first one. So we're going to use a row, so like the first row or the second row. And then of the second matrix, we're going to use columns. Okay, so we have 3 different columns that we're choosing from. If you look at these, there's 2 elements I circled in the first matrix, and there's 2 elements I circled in the second matrix. That corresponds with these middle numbers here. This 2 here and this 2 here, where they had to be in agreement. So when you're looking at combining these, there should be the same number in those circles that you have. So what we're going to do is this first number I'm trying to find here is in the first row, and it's in the first column. So I'm going to start with the first row that I have circled here now, and the first column that's also circled. So whenever I want to talk about rows, I'm looking at the first matrix, and when I want to talk about columns, I'm talking about the second matrix. So when I multiply, I'm actually going to have 2 products here because I have 2 numbers in each of those groups. So I'm going to do the 3 times negative 1. I'll color code this according to my rows and my columns. And then it's going to be plus a negative 1 times a 4, since 4 is the second number in the column. Now if I go to the next number over, this is going to the second column. So I'm going to move this over to highlight the second column. 0 and negative 2 are the numbers I'm going to be using for the column numbers. So again, I'm going to start with that first row of 3. And then my first number in the column is 0. plus negative 1 is the second number in the row, and negative 2 is the second number in the column. To complete this row of my matrix, I need to go to the last column and use the 5 and 6. So again, it'll be a 3, first number of the first row, times 5, first number of the last column, plus a negative 1 times 6. So now I have my first row complete. I'll just have to evaluate what those numbers are. So now I'm going to move to my second row. So down here in the second row, I'm going to work with the first column. So now I'm always going to be using my 2 and negative 3. I'm going to start back over here at negative 1, 4. So 2 times a negative 1 plus a negative 3 times 4. Then I'm going to move to my second column. I still stick with the 2 and the negative 3 for the second row. 2 times 0 plus negative 3 times negative 2. And then I finally move to my last column. It's my last row, last column, the bottom right value. So 2 times 5 plus negative 3 times 6. So sometimes you might end up with a matrix that is much bigger than your original 2, just based upon those outside numbers of your resulting matrix, or it might be much smaller because of those outside numbers. So when I simplify this, so in the first one here, I have a negative 3 and a negative 4 will make a negative 7. I have 0 and 2, so I'll have 2 there. 15 and negative 6 will be 9. My second row, I'll have negative 2 and negative 12, so negative 14. And I'll have 0 and 6, we'll add up to 6. And I'll have 10 and negative 18, so negative 8. So this is my resulting matrix when I multiply them. Again, it's not that intuitive for it. We do really need practice on this and instruction for this. But it is a way of really merging two matrices together, which are really like a table between them. If I look at some of the similarities in my chart here above, that color-coded, if you look all the way, if you go on across, those red numbers are the same in those rows. If you go vertical, the blue numbers are the same. So you're repeating using those numbers throughout. So some of the things that are really helpful is if you set up your resulting matrix with those lines so that you know how many numbers you're going to have in there. And then the other thing that's really key is make sure you circle your rows and columns. I'd even circle all of them when you're doing that if you don't have the luxury of moving it throughout. And so then you really know that with one of them you're always working with rows and you have the visual for the other one always using columns.